All right, simple interest. So starting off with financial maths, we usually start off with simple interest because it's the more straightforward sort of concept. And then compound interest is probably more usable with your home loans, etc. Those who do general maths will use a bit more on compound interest. The idea of simple interest is the idea that you either earn or you owe money, which, like any loan, you can either invest money or you can borrow money, right? Simple interest formula. So for those who need a copy, this is all you need to copy down. Just this part of the formula. I equals P times R over 100 times N. This is the formula for if I said simple interest. Okay, so just make sure you have a title. It's called Simple Interest. For the Year 12, this is 9.2, exercise 9.2. The formula is I equals P times R over 100 times N. If you aren't familiar with this formula, then the little notations underneath will tell you what they are. I is the interest. If you don't know what interest is, it's the money you either owe or it's the money that you gain. This is what it kind of looks like logically. If you had a bank account, a savings account, for example, you put money into it, the bank essentially holds onto your money. So they like that because they now have made money from you. You gave them your money. So what they do is they say, if you leave it with us, you don't spend that money. That's why it's called a savings account. You don't spend that money. They get, say, your $100 that you put in. They get to use that $100, whatever they want to do. Right? They can lend it to someone else, and then they pay them interest. They get that extra money, and then they pay you. So they say, if you leave it for $100 for a month, for example, so in a month you didn't even touch that money. You didn't spend it. You didn't take out. They essentially had a whole month of using your $100 for whatever it is that they do. Yeah, they're investing your money. If you leave it there, then they'll say at the end of that month, they'll give you back a bit extra. That extra is what we call interest. Okay, so if you gave them money, they'll give you a benefit. They'll say, well, cool, thanks for choosing our bank. We'll give you a bit extra if you leave your bank account at $100. Then whatever that is, they'll give you a percentage back. That's called interest. Yeah. Similarly, if you lent or you borrowed from them, so if you were another account and you needed money, then you would borrow. And they're like, yeah, I'm happy to give you money, say $100. But after a month, if you don't pay me back that $100 that I lent you, well, usually it's calculated per day, they'll charge you a bit extra. So the same little extra, instead of you gaining money, you're now losing money. So it's called owing. So both of them are interest, but you're either interest in investments, so you're gaining money, or you're either having interest in owing money. That's why if you don't pay back your loans and mortgages over the years, percentage on a very large amount becomes a really huge undertaking. And statistically, people who are from 18 to 25, especially in Australia anyway, have huge credit debts, mainly because right after high school, they spend on going to the prom and, I don't know, limousines and hiring dresses, etc., and what are tuxedos or whatever it is. They rack up a huge amount at the start, but when you work, you don't actually earn that much. And if you keep spending and you're not budgeting, $1,000 doesn't seem a lot at the start, but over the years, if you rack up the interest, especially with credit cards, they go up to 20% interest. You take 20% of 1,000, and then you take 20% of 2,000. It just compounds, starts to add up. And so statistically, from 18 to 25, there are a lot of people within that range who are credit debt of about $10,000 to $20,000 in debt. And if you think about it, that's not even just what you owe. That's $20,000 of what you need to pay in interest and whatever you owe. So if you think about the money that you earn in a year, if you keep doing that, it builds up. So simple interest is easier to understand because it only works on one amount. So here's the idea of simple interest. If you put in $100, right, and they said they'll give you 10%. Okay, I'm making it easy. Actually, I'll make it easier. Say 50%. If for every day that you keep your $100 there, they'll give you an extra 50% in interest. So $100 is still there on day one. they'll give you extra 50% of whatever's there. Now, what's 50% of 100? 50. So they'll give you in interest an extra $50. So that means after day one, you now have $150 in your bank account simply by leaving your money there. That's called interest. That's your principal. That's the amount. What makes simple interest different to compound interest is that even in day two, even though you now have $150, it's not 50% of 150. It's still 50% of what you initially put in. So you still gain, on the second day, you still gain $50. This is called simple. So that means day three, thanks Jasper, day three, day four, it doesn't matter what the amount is, it's always plus 50. That's why it's called simple. Okay, so it's simple because you can predict in 10 days, it's 10 times $50, so you make $500. Compound interest will actually calculate on whatever's left in the bank. That's why it grows exponentially. Okay? All right, so that's what this formula is actually doing, is just simply taking what did you put in, what percentage. So mine was 50% just now. So put in the amount 100, 50% of it, for how long. That's why it works. So simple interest is based on that idea. Okay, so this is how long. This is how much did you put in. And this is your percentage rate. So I said 50% just now. So you times all those together, you will get the interest, which is what you either earn or what you owe after the how long. Okay? Usually how long is in terms of years. So usually it's in terms of years. But that will tell you. Cool? Let's do an example. So what did you have to copy? Hopefully you only had a title and then you had the formula. The rest was just me explaining what it is. Okay? Let's do now an example. Calculate the amount of simple interest earned. So they tell you it's simple interest earned and the total amount, okay, at the end of a term deposit if you invested $12,000 for 5 years at 9.5% per annum. Okay? How would you work that out? Well, first thing is we need to know how much interest you're going to get, how much gain, how much money you're going to get from putting $12,000 into a certain bank account for 5 years. They get your $12,000. They have to give you something back in return. So what they do is they give you 9.5% of whatever you've left there every year. That's what per annum means. So every year they'll give you an extra 9.5%. So here we go. $12,000 is your principal. That's how much you started off with. You invested $12,000. Your rate, they told you is 9.5%, which really is the same thing as saying 9.5 out of 100 per year. That's why the R is 9.5 and it's out of 100. N, which is 5 years. When you do this, the only thing you got to check is the rate the same as the duration. If I said 5 months, and this is the rate per year, then you can't just sub those numbers in. They won't work. You have to make sure these two are the same. Okay? All right, here we go. So if you do it on your calculator, this is what it'll look like. It'll be $12,000 times 9.5 over 100 times 5. So what do you copy next? This is what I want you to write down. So you got your formula. I then want you to write this bit. To help remind yourself in this scenario, $12,000 is what you invested. R is the rate, so 9.5. 5 is the duration. Make sure these two are the same units. So they both have to be in years. Let's do it on a calculator to see what it equals to. Here we go. $12,000 invested times 9.5. Sorry, I'll do it if you have a scientific calculator. You do 9.5 divided by 100. So that's your rate. Times 5 years, because it is 9.5% per annum. So 5 years makes sense. You get $5,700. So write in $5,700 in interest. So that means when they ask you for the total amount, you didn't get $5,700 in total amount because you put in $12,000. So $12,000 plus an extra $5,700 gives you $17,700. So at the end of 5 years, you essentially earned an extra $5,700 without doing anything. You simply just put it in and you get your money back. Yeah? Usually it's about the 5 to 6% usually. Unless they have a promotion or something. Could go up. But yes, 9.5 is pretty high. Per annum. So there you go. So that's the idea of simple interest, and this only works if it's consistent every single day or single month. They charge by interest that's the same. Okay? So interest is $5,700. Did you have to copy all of that? No. I just wanted you to have formula, how to do the question, and know the difference between principal and interest. Another thing to copy down as part of your notes, you can derive this yourself. So if your algebra is strong, you would have been able to figure out the rate formula just to work out the rate. You could also rearrange it to get the duration. And you can also rearrange it to get the principal. But if you're not strong with the algebra, please copy this down. Those three formulas will be useful. They all come from the same one formula, but I've rearranged it for you. So that way it's just ready for you to copy down when you get a problem like that. So one for rate, one for duration, one for principal. And then we'll do one example in the next page, just how I would use one of these formulas. And that's it for today's lesson. Simple interest. Should have copied it down. So, boys, can we not throw these in my class, please? Thank you.
Yeah, you guys did.
Stop.
You were nearly 18.
It's good that you guys can say that. All right, let's move on to the next example. So next example relies on one of these formulas. Here we go. Example 2. Let's say it's the reverse. You want to calculate how long should you put in an investment of $255? Okay, so you got $255 in your pocket. You know it's going to be a simple interest, and the bank pays 8.5% per annum. And you earned $86.70. So the question was, how long did you put in there to earn an extra $86.70? The formula is already given to you, so I've given it to you, or you could have rearranged it yourself. Okay, so that's why I asked you to copy those three formulas down. Because we're looking for period of time, you're looking for N. So how long do you invest it for? You invested $255. So P equals 255. Simple interest, so your rate is equal to 8.5. And then I, which is the interest you gained, you got 86.7. So putting it all together, N will equal on your calculator as 100 times 86.7 divided by 255 times 8.5. Okay, so I gave you those three formulas. I'll go back to it so you can copy it down again. But here we go. On your calculator, we're doing 100 times 86.7 divided by, now this part you got to be careful. Because it's P times R on the bottom together, if you do it on the calculator, your scientific one, and you don't put in the brackets, you could get this wrong because they will work from left to right and it will assume that you're doing 86.7 divide this, then times that. Those are two different things. So if you want to actually write this on your scientific, you have to put a bracket in between them. Okay, so it has to have brackets because those two come first. So here we go. Make sure to put the brackets in. It's $255 investment times by 8.5. And you get 4. Watch what happens if I do it the other way. If I do 100 times 86.7 divided by 255 times 8.5, see how I get a different answer? If I don't put in the brackets before, it doesn't know it's in the denominator. This is what most students would do on a scientific calculator. When you got a question, does that make sense? $289 or 289 days or years just doesn't make sense to earn only $86.07. Okay? So you got to think about it. This is saying it's 4 years now. So it takes 4 years, not 289 years. Okay, so make sure to put the brackets in. If you don't put the brackets, you'll get it wrong with a scientific calculator. So the answer should be 4 years. Do it wrong, it'll be 289. So if you're doing the calc, just double check that you know how to do that. But that's it for today's lesson. So here's your 3 formulas. Make sure to copy these 3. It's just the rearrangement of the first one I gave to you. But if you know your algebra, you can get all these 3. Okay? We'll stop there, team. Remember, I'll be checking your chapter 4 at the end, or maybe start of next week, to make sure that you are not too far behind. So percentages should be done. You should now be working on linear algebra.
So what's the new percentages?
Sorry? You